Welcome to the Vestibule's Understanding the Commercial Energy Code Requirements training video brought to you by the U.S. Department of Energy. You now can receive 0.10 CEUs towards IECC renewal certification and or 1.0 AIA CES learning units. However, in order to obtain AIA LUs, new AIA requirements dictated tests must be taken. At the end of the training video, you will be directed to a website to take the 10-question test, applicable to AIA members only. You must answer 8 of the 10 questions correctly in order to qualify for the 1.0 learning unit. BECP will report the AIA members who pass the test so credit can be awarded. A certificate of completion will also be available at the end of this training video.
Hello and welcome to the Building Energy Codes program on understanding the vestibule requirement in the 2003 International Energy Conservation Code. This is Makela. I'll be your instructor for the next hour. The 2003 IECC currently requires vestibules on entrance doors in many commercial buildings. The requirement came into the code in the 2001 supplement with its roots based on the ASHRAE/IESNA 90.1-1999 requirements. Several questions have come up from a vestibule requirement standpoint as states start to adopt this. 2 states, New York and Texas, have had this since approximately 2001. Since its adoption, there's been several issues from designers and jurisdictions on how to enforce the code requirement because, unfortunately, within the IECC, the requirement is not as clear as it should be. Several of the questions that have come up, which entail which entrance doors must have a vestibule requirement, when is a space, because it's not entirely clear within the code, and how can I exempt my project, which is a very popular one. The purpose of today's webcast is to answer these questions and several other ones that have also popped up on vestibules. When we put this presentation together, we based it on the ASHRAE 90.1-2001 requirement and Chapter 8 of the 2003 International Energy Conservation Code. We also pulled in sections from the 2003 International Building Code with the primary attempt to eliminate as much gray area as possible with this code provision. Hopefully, the 2006 IECC commentary and ASHRAE subcommittees will formally draft up guidelines in the near future, but until then, we're going to go ahead and present the requirement as it is in the code. What we're going to be covering today, first we're going to go through a review of the IECC and the ASHRAE 90.1-2001 vestibule requirements. We're going to look at the purpose behind the vestibule requirement. We'll look at the basic vestibule requirements that will deal with primarily the basic requirements for doors, glazing, and the building envelope that surrounds the vestibule. We'll look at a definition of space, which is going to be key and critical in getting us to understand when a vestibule is going to be required with the code. We'll look at which doors must comply with the vestibule requirement. And then we'll look at a couple of examples of complying with the building envelope requirements for portions of the vestibule to try to clarify what parts of the building have to comply with the envelope requirements and which parts are exempt. Following that, we'll look at additional vestibule considerations that primarily deal with the International Building Code, and at the tail end of the session today, we will have time for questions and answers. Okay, so let's dig into what the code requirements look like. In the 2003 IECC Chapter 8, Section 803.2.6 under vestibules, it basically states that doors that separate conditioned space from the exterior, and that's a key word to remember, must have vestibules. There are several exemptions to this vestibule requirement. One of them are buildings and climate zones 1A through 4B as indicated in Table 302.1. Essentially, this includes Gulf Coast states that are fairly warm, humid climates, and from a cost-effectiveness standpoint, it's really not worth having the vestibule there. Doors not intended to be used as a building entrance door, such as doors to mechanical or electric equipment rooms. This one is important that the primary focus of our requirement is going to be on doors that are used primarily for the general public coming into and out of the building, not doors that are very rarely used and may just have personnel use. Doors opening directly from a guest room or dwelling unit. Remember, the 2003 IECC commercial provisions cover cover multifamily type of construction, 4 stories or more, so it is a possibility of having a large dwelling unit on the first floor that could actually have a space greater than 3,000 square feet. Getting into our next one, doors that open directly from a space less than 3,000 square feet are exempted in an area. Now this is going to be a big one because this will basically is the trigger point of when a vestibule is required. If you have a revolving door, you're exempted from the code too. And then last but not least, doors used primarily to facilitate vehicular movement or material handling and adjacent personnel doors. Again, we're not looking at doors where the general public comes through. These are special doors with special needs in a lot of commercial buildings. So again, these are the exemptions within the code. ASHRAE 90.1 has the identical requirement, but the biggest difference is that doors in buildings less than 4 stories above grade are exempted from the vestibule requirement. So most buildings that comply with the ASHRAE 90.1 2001 requirements that are 3 stories and less will be actually all buildings 3 stories or less will be exempted. 4 stories and above will be fair game from a code requirement standpoint. The first exemption, doors in buildings and climates that have less than 1,800 heating degree days, base 65, basically relates to the same climate zones as the IECC, which is climate zone 1A through 4B. So we're looking at essentially the same type of climate zones within 2001 that are exempted as in 90.1 2001. But as you can see, as we run down the list here, the same exemptions hold true within Chapter 8 or within the IECC. One of the questions that comes up is how can I exempt my building from the vestibule requirement? This is probably the biggest exemption, but bear in mind that if you comply and take the exemption with vestibules in 90.1 2001, it means that you also need to follow the requirements and the envelope requirements within the ASHRAE standard and complete them in its entirety. Okay, so we've got this requirement. We need to figure out what's important about this requirement. What is the code actually trying to accomplish? Essentially, the codes are trying to eliminate as much infiltration in commercial buildings as possible. So if we look at the left hand, the wind section over here, we end up with infiltration from a wind load on a commercial building. Now, if this building is 4 stories and above, even in ASHRAE, this building would not be exempt. In the IECC, this building is not exempt. And you've got a wind load coming down through here into the opening into the building, and that creates quite a bit of infiltration. I think one example you can think of is the cashiers in some of the cashiers in some of the grocery stores that are wearing their down parkas in the middle of the wintertime, because every time the automatic door opens up, it lets a wind load into the space, so they get pretty cold there. So this would be fair game from a vestibule standpoint. The other requirement would be the stack of the air infiltration would be from stack effect. Typically, taller buildings you have much more stack effect than with shorter buildings. Stack effect is the naturally occurring warm air that rises up into the building, and actually it pulls colder air in from down below. So you can see the cold air coming in here, the hot air rising up there, creates a negative pressure and actually pulls in the air into the lower parts of the building. So taller buildings, again, have a greater potential for stack effect, but this is another way that infiltration can get into the building. So from a vestibule standpoint, the key is trying to eliminate infiltration into that space. The very basic vestibule requirements. The first bullet here, entrance doors and space is greater than or equal to 3,000 square feet. This is key because this is really the trigger point on the requirement. If the space is less than 3,000 square feet, you don't need a vestibule on that primary entrance door into the building. So the other thing you need to look at is the entrance doors leading into and out of the vestibule. So you would look at this, and this must have self-closing devices. So basically, you need to be able to enter the vestibule, have the door close behind you automatically, and then be able to exit the vestibule and also have that door close automatically. So that's a very key element on that. Most exit doors already come equipped with self-closing devices, so that shouldn't be a big thing. From a size standpoint, how deep this vestibule has to be, in the IECC, it basically says that it must be able to pass through doors without needing to open doors at the same time. So you need to be able to enter the vestibule, have the doors closed behind you, and then leave the vestibule without having to have both sets of doors open to be able to enter and exit the vestibule. There are other requirements in the IBC that deal with egress, and we'll talk about those a little bit later as far as the depth and width of requirements for a vestibule. As we stated before, the enclosed vestibule has to have the ability to walk into the vestibule, have the door shut behind you, and then leave. So the example on the upper left-hand corner will have the door leading into the vestibule. You can enter this particular vestibule, and then you can exit through the exit doors there, but this will give you ample space to be able to get into there without problem. The bottom right-hand corner shows a self-closing device on the door, and again, this would meet the intent of the code for a self-closing doors. Okay, what happens if I have a 3,000 square foot space with two entrances? And this is going to be a key one because oftentimes you're going to get a configuration that will have a central lobby area in an office building with the actual offices off to each side as shown on here. Here's one office here. Here's one office here. Here's a central lobby area that will assume for this purpose is greater than or equal to 3,000 square feet. From this standpoint, you could argue that both of the doors here and here are primary entrance doors into that space. One's leading off from parking lot, the other is leading off from the street, but they're both primary entrance doors into that 3,000 square foot space. So under the IECC, both doors would need to have vestibules on those doors. Okay, let's take a look at what we're talking about from a space standpoint. If you get into the IECC and look at the term space, you'll find that space is not defined within Chapter 2 of the definition section. But space is defined under ASHRAE 90.1, 2001, and ASHRAE 90.1, 1999, depending on the code you're looking at. So if we look at the term for enclosed space, we have a volume substantially surrounded by solid surfaces, such as walls, floors, roofs, and operable or openable devices, such as doors and operable windows. So what this translates to is an area surrounded by floor-to-ceiling partitions. It's got some type of a roof on it, and there could be openings in that partition, but the openings have doors or some type of window in there to basically plug the holes up, if you want to look at it that way. The next slide we're going to take a look at actually would show the definition of the space based on the ASHRAE definition. In this case, we've got some windows on the sidewall here and here. I've got doors leading into and out of this conditioned space. So these doors you'd be able to open and close and go through there. So essentially, the conditioned space here would not communicate with this hallway corridor area right here. The walls would be floor-to-ceiling height partitions. There probably will be a roof over there or a floor over the top of this to basically show that to be a fairly enclosed space. So by definition, from an ASHRAE 90.1 2001 standpoint, we could consider this area as space, and if this space were greater than or equal to 3,000 square feet, we would need a vestibule then off of these exterior doors. But now let's take a very common example. What happens if we have a space that actually communicates with another space? So our conditioned space here's our exterior doors here and here. We have the exterior out here. We have an interior conditioned space right here. This area is only 2,000 square feet. But the conditioned space in the hallway is 1,500 square feet. Now, this could be a hallway in an office area that empties out there with no closable doors here or here. This could be another office suite or something like that, but basically this conditioned area of 1,500 square feet communicates with the conditioned space of 2,000 square feet. So the question is, do we add the square footage up for the 2,000 square feet and the 1,500 square feet to determine our 3,000 square foot total on this one and our trigger point? Again, the code is a little bit unclear on this. It doesn't tell us what to do. So we could actually go into the International Building Code and start to use some of the definitions there to determine if we should add these two spaces together. If the air from this conditioned space of 2,000 square feet basically can communicate with this conditioned space of 1,500 square feet, one could assume then that you're going to get heat and cool transfer through these openings, and therefore you should add up the 2,000 square feet and the 1,500 square feet. But it's always nice to have a code provision that you can back this up on. So if we go into the International Building Code, we'll see under section 1203.4.1.1 of the IBC, which deals with natural ventilation, that if you have openings basically at 25 square foot minimum or greater, we can assume that there will be heat transfer from the exterior space into that interior space, because you're also assumed to be able to get natural ventilation from the exterior space where the ventilation is coming into an interior space, but as long as you have at least 25 square feet or 8% of the floor area of that interior space. So 25 square feet will be the minimum amount that you can have. So if we take this one step farther and look at the same condition, if these spaces, if these openings in the wall between the 2,000 square foot area and the 1,500 square foot area, it's greater than or equal to 25 square feet, we could assume that we will have heat transfer where these red arrows are from this conditioned space here into this conditioned space down here. So by code, we should be able to add the 2,000 square feet plus the 1,500 square feet, come up with 3,500 square feet, and essentially call that our entire space, in which case these exterior doors here and here would be required to have a vestibule on those doors. Now, what happens if we eliminate, we'll eliminate this space, this door right here, and we'll have one door area that we'll say is 24 square feet. In that case, I would say that this space would not need the vestibule requirement because the opening here would be less than 25 square feet, and therefore these doors would be exempt. What happens if this space or this doorway and this doorway open up into two separate rooms? So we have a room over here, we have a separate room over here, we have 24 square feet here, 24 square feet here. Again, I would say that the conditioned space here, you would not add that square footage with either one of these two spaces to come up with the 3,000 square feet because of the 25 square foot rule. Again, this is not in the IECC. It's basically taking a look at the natural ventilation requirement within the International Building Code and applying those principles to this type of scenario. Okay, so now we take a look at what types of doors are exempted from the code. And when we get into the code provisions, we see doors used primarily to facilitate vehicular movement or material handling and adjacent personnel doors. So, upper left-hand corner, loading dock on this picture right here, this loading dock door would fall underneath the material handling and adjacent personnel doors. Bottom left-hand corner, we have a mechanical room here, we have electrical room here. Again, those are not for the primary purpose of the general public getting into those spaces, and they would probably enter onto spaces less than 3,000 square foot anyway. The bottom right-hand corner, we have a door for personnel use only, and this particular door is actually labeled for employee entrance only. So this particular door, again, would be exempted from an IECC requirement. Now, we can take this one step further. Some of the large owner-builder stores, like a Lowe's or a Home Depot, have several different doors leading off of those buildings. We have entrance doors, exit doors, we have doors leading out to the nursery, we have doors where they drive forklifts through. Some of those can actually be exempted from a material handling and adjacent personnel doors, but you need to basically take those door by door to determine what's your fair game and which would be exempted from the code. But you do need to look at each one closely to determine what the usage is of those particular doors. Okay, also from a door requirement, we talked about the ability to have self-closing doors. So, what you can use, power-operated doors, the upper right-hand corner, this is a power-operated door. This would be fine. These are used quite extensively in a lot of buildings. A standard self-closing door that we looked at the very beginning of the presentation, again, this would meet the intent of the requirement. There are some doors out there, though, that are not to be used. For example, an air curtain. Some large box stores actually use an air curtain between the vestibule and the conditioned space. From a code standpoint, there's nothing that calls out in the code that says you can use an air curtain. It basically uses the word self-closing doors, and I would say that an air curtain would not be considered a self-closing door. So within ASHRAE or the IECC right now, there's no requirements or nothing that will allow you to use this particular device from a self-closing door standpoint. Also, roll-up doors. A lot of the box stores also happen to use roll-up doors on the second door. They have a vestibule setup, maybe with cart storage on the outside, roll-up door on the inside. Again, unless you put a self-closing device on the roll-up door, which would be somewhat impractical, that would not qualify from a vestibule requirement standpoint. We're bringing up some of the owner-builder stores like the Lowe's and Home Depots. Again, from a material handling standpoint, this is where you may be able to exempt some of those doors if they're using a roll-up door for material handling and that type of thing. Because again, you're bringing lumber and things like that through the doors, and a vestibule would actually get in your way in that scenario. So, and those doors would typically be open quite a bit of the time anyway. So you could probably exempt a lot of those doors if they're roll-up doors, but you do need to take it case by case. Another non-compliant door, and in this case, we need to take a look at this and determine which of these doors would be fair game and which would maybe be exempted from material handling. The entrance doors into this particular store, if you're not pushing materials in there, could be considered fair game from a vestibule standpoint. The exit doors on this, depending on what the particular store sold, you might be able to make a case that you could exempt vestibules off the exit doors. But again, this is another case-by-case standpoint. You need to really take a look at the need of the building to determine, is it exempt, or do you actually need to comply with the code for this particular door? Now again, under ASHRAE 90.1/2001, this particular building could be exempted entirely from the vestibule requirement standpoint. And also the two scenarios we looked at with roll-up doors and an air curtain could both be exempted under 90.1/2001 if the buildings were less than 4 stories. Here's a common example of a school. This particular entrance is into a gymnasium. So we've got an entrance door here. We have an entrance door here. The space behind this entrance door is 3,000 square feet. These doors are primarily for the general public to come into and out of, or are going to be used quite a bit. So these doors would be fair game from a IECC vestibule requirement standpoint. But the purpose behind these doors on the gymnasium itself are more for egress, and they aren't going to be having a lot of the general public going into and out. So from an IECC standpoint, you could exempt these two doors in addition to ASHRAE 90.1. Again, these two doors would be exempted. So the intent would be to hit these primary doors where the must comply arrows and the yellow circles are hit. So those would have to comply with the IECC. Okay, another exemption is revolving doors. If we get into the IBC requirement, though, the IBC requires side hinge swinging door no greater than 10 feet from the revolving door. So the question is, the revolving door is exempted from the vestibule requirement. Is the side hinge swinging door exempted also? I would maintain that the revolving door was fair game. The side hinge swinging door would be exempted because that door is there primarily from an egress standpoint, from a handicap access standpoint, and it's really not part of the main public entrance into the building. Oftentimes you'll also see signs saying, please use a revolving door. So the revolving door would meet the intent of the IECC, but the side hinge swinging door next to it would be exempted. I would maintain it would be exempted from the code, and you wouldn't have to worry about that from a vestibule requirement standpoint. So we've taken a look at several different things. We've looked at the IECC and ASHRAE requirements, so we know exactly what the requirements are. We've looked at the purpose behind the vestibule requirement. We've looked at some of the basic vestibule requirements. We've defined space. We've looked at which doors must comply with the IECC vestibule requirement. Now we're going to get into complying with the building envelope requirements for the portions of the vestibule. And this is going to be a key issue because we need to know which of the walls and glazing assemblies and door assemblies have to comply with the IECC, and which of these are going to be exempted, because this could make or break energy code compliance with a commercial building. If we look at the particular example that we have up, the red wall on here is considered the wall between the conditioned space and the outside. So the red wall would be considered our exterior wall. The IECC essentially says that exterior doors must have vestibules on them. So the door that we're looking at, the entrance door here and here, would be a door between a conditioned space and the outside until we get the vestibule on that. Now, from a code standpoint, as soon as we put an enclosure around a space from an IECC standpoint, it all of a sudden becomes an unconditioned space. So this unconditioned space can be very much similar to a unconditioned warehouse, for example, which would make the wall between this conditioned space and the vestibule by code an interior wall, defined by code. And basically an interior wall is a wall between conditioned space and unconditioned space, and it's defined differently within the IECC and handled differently within the IECC than an exterior wall. So glazing doors and opaque wall area within that wall would need to comply now with the interior space requirement, which would mean it would have to comply with the 0 to 10% prescriptive packages within the IECC, and we'll take a look at that in a second. So this vestibule area, one could say, now becomes unconditioned space. From an IECC standpoint, this wall surface around unconditioned space is exempt from the code. So glazing, walls, doors would be exempt from the code between the unconditioned vestibule and the outside, and then we would need to worry about the surfaces between the conditioned space and the vestibule and figure out how to get those to comply with the IECC. If we take an example in Climate Zone 12B, this is a prescriptive specification package from the 2003 IECC from Chapter 8 for Climate Zone 12B. Again, just to repeat, the interior wall requirements by code must meet the 0 to 10% requirement for those particular surfaces. We're going to be looking at walls only because if we have a floor over that vestibule, a floor over unconditioned space would have to meet the floors over outdoor air unconditioned space requirement. But from a wall standpoint, the first thing we look at based on our wall type, let's assume, and the circle shows we're going to have a framed wall. If we have a metal frame wall, the wall would have to be insulated to an R11 insulation. If we have a wood frame wall, the wall would have to be insulated to an R11 insulation. So the minimum R value requirement within the prescriptive code, prescriptive specification approach, would be an R11 for any framed wall. If we have concrete masonry unit or other masonry types of wall systems, depending on how we do that, we will either need an R5 insulation continuously or an R11 insulation if we choose to frame out that wall system and insulate that. So we have an R5 or an R11 for concrete masonry. We have an R11 for framed wall. So that takes care of our opaque wall assemblies. Now, what happens if we have windows and glass doors, which is fairly common going into a vestibule? In Climate Zone 12B, we'll see that for solar heat gain coefficient, we can use anything we want. There is no requirement. So clear glass would work to meet the SHGC requirements for the glazing between a conditioned space and that unconditioned inside the vestibule. U factor is the same way. We can essentially put in any window we want to between those two assemblies from an IECC standpoint. Now, there might be other IBC requirements on what that glass must be made of and things like that, but from an energy code standpoint, under Climate Zone 12B, essentially we can put in any U factor or SHGC glass door, opaque door, or window between those spaces. The other building assemblies, if again we have a floor over that space, so a floor would be over unconditioned space, we would go ahead and determine what our minimum R value is going to be, either by installing the insulation inside the framing or continuous insulation. Slab edge insulation, the slab between the conditioned space and the vestibule is considered a slab edge. So in this case, we would need to use a slab or below-grade wall insulation requirement, and determine what the R value is going to be for that particular surface. So again, from an IECC standpoint, prescriptive standpoint, this is how we would go ahead and handle that. Now, from ComCheck EZ are right now investigating the issues dealing with vestibules, and they are under review from a software standpoint. So right now, prescriptive specification would be the best way to handle those particular services. Here's a case study, just an example. We have our unconditioned space. Here is a very small vestibule. We have the exterior door leading out of the vestibule. Where the arrow is pointing is actually the unconditioned space formed by the vestibule, and then we have in the background the wall between the conditioned space and the vestibule would be again considered an interior wall. So that would be compliance with the interior wall requirements. What happens if our vestibule pokes inside the building? Well, again, this is a very common consideration in a lot of vestibule requirements, especially in areas where by code and by regulation and things like that, you cannot put a vestibule off the front of the building. So it would have to actually stick inside the building. In this case, we have our conditioned space in the area where I've just put the yellow circle. Outside the building is right here. We have our unconditioned space, again, formed by the vestibule. So our vestibule area where the red goes around actually forms the unconditioned space. This would be handled identically to how we just handled the first instance. The red wall between the conditioned space and the vestibule would be considered an interior wall. The red wall between the conditioned space and the outside is handled identically to an exterior wall requirement, just like you'd ordinarily do that. But the red wall again between the conditioned space and the vestibule would be handled as like an interior wall, as with the glazing, as with any glass doors leading into that space. Okay, so again, we've handled the IECC requirements on this. We've looked at what a space is. We've looked at the door requirements. We've looked at what's conditioned space and unconditioned space, and briefly talked about how do you get this thing to comply with prescriptive specification requirements within the code. The last thing we need to look at are other vestibule considerations, and there are several. The IECC specifies that you need a vestibule, but you need to dig into the IBC to actually find out how you're going to build this and what the minimum specifications are as far as depth and width within the vestibule requirements. There are several things to look at. One of them is the IECC ANSI A117.1-2003, the accessibility requirements, which basically require that the vestibule be a minimum or at least a minimum size. One is so that you can get a wheelchair inside the vestibule and be able to turn the wheelchair around. From a code standpoint, the code basically says that you need a minimum distance of 48 feet from the door swing, from basically this point to the other door. So minimum 48 inches plus the width of the actual door itself. So typically, from an ASHRAE standpoint, they mandate a minimum of 7 feet. From an IBC standpoint, if your door swing, for example, is a 34-inch door, you would need at least 34 inches plus 48 inches, or 72 inches. That would be the minimum depth of this vestibule to be able to build this. There's other requirements as far as exit discharge that are handled under IBC section 1023. There's a new requirement, which again is a new requirement for vestibules within the IBC. IBC section 1008.1.7 also covers the same requirements as ICC ANSI A117.1-2003. If you're using this for egress, there's also several requirements that deal with egress within the IBC. So you definitely need to pay attention to the IBC requirements when you're designing the vestibule for your particular building. Well, this ends the vestibule presentation. If you have any questions, go ahead and email them in, and we will take them as they come. Thank you very much.
This ends the training video. If you would like to take the test to receive AIA credit and or print a certificate of completion, please write down the URL shown on the screen. You will need to type this URL into your internet browser. Thank you.